Okay, our next example, this time we're not dealing with a polynomial. Of course, being to the 1/3 power is the same thing as a cube root. The thing about a cube root though is you really don't have to worry about anything with it because you can take the cube root of any real number. It doesn't matter whether it's a positive number or a negative number. It would just be with square roots, remember that you'd have to worry about because you would not be able to take the square root of a negative number. But that's not anything to worry about here since we are dealing with a cube root. So we'll go ahead and proceed with this just as if it were a two-sided limit. So we are finding our derivative specifically at 3 for this function. So I would have the limit as x approaches -3. All right, the numerator starts off with just the function. And then you subtract from that the function evaluated at -3. So if I were to substitute -3 into my function, and then I have to divide this by x minus -3, so therefore that'll change to a plus. Okay, this is going to end up giving us 0, so again this portion of it basically just goes away. So we have x plus 3 to the 1/3 power divided by x plus 3. Again, if you did your direct substitution right now, you would get the indeterminate form. So there's some more simplifying that we can do. You actually have exactly the same factor. You've got x plus 3 on the top, and you also have x plus 3 on the bottom. Of course, on the bottom, this is understood to be to the first power. So since you have that same factor, numerator and denominator, you can cancel some of that out. Now, of course, this being a fraction, you may hesitate just a minute about how to handle it, but if you just remember your exponent rules, what you're supposed to do is subtract your powers. So if you do 1/3 minus the 1, because you would have to do the top minus the bottom, that's going to give you a -2/3. Now, because of that being a negative, what you would want to do is write that in your denominator, which would then cause it to be positive, because remember, if it's negative, you move it to your denominator, and therefore it'll make it positive, which would leave you with just an understood 1 on the top. Now, if you do your direct substitution, then you're going to end up with 1/0, which would indicate that this is actually a situation in which the derivative does not exist. So this would be a function that is not differentiable at -3. I know we're doing a limit. Limit does not exist, but then that tells us that it's not differentiable at -3. Now, I could take the same function, change this to a different value, and I might be able to get it to be differentiable. So just because I get does not exist here doesn't mean that this is not differentiable everywhere. It's just all we've proved is it's not differentiable at x equal -3. And actually, if you were to look at the graph of this, the reason why is at -3, you would have to have your tangent line being vertical. And if you remember, that's one of the situations where it's not differentiable. All right, one more example of using this alternate form. And this time we're going to be working with absolute value. Now, when it comes to working with absolute value, we are going to have to look at it as one-sided limits. We're going to have to set it up and look at it from the left and look at it from the right. Okay, so let's start with the derivative of 4. So I'm going to take the limit as x approaches 4. We'll just do from the left first. Now, when you go to write your function, because you are looking at it from the left-hand side, what you're actually going to have is going to be the negative of this. So you'd have the negative of x minus 4. Then you have to subtract from that the function evaluated at 4 divided by x minus 4. So again, this portion is going to end up giving us 0. So like that's going to be gone. So I have the negative of x minus 4 over x minus 4. This is going to simplify because those will cancel out. And I have the limit as x approaches 4 from the left of just negative 1 because I had this negative. But the limit of a constant, remember, is just that constant. Okay, now if I look at it from the right-hand side, what's going to be different about setting this up, like where I had to do the negative of x minus 4 because I was coming from the left, this time you'd do the positive of x minus 4 since we're coming from the right. Well, the positive of x minus 4 is just x minus 4. Okay, then you subtract from that the function being evaluated at 4 divided by x minus 4. So again, this portion is going to just give me 0, so I'm left with just x minus 4 over x minus 4. So those are going to cancel out, which would leave you with just an understood 1, and the limit of a constant is that constant. Now, when you're looking at one-sided limits, remember for the two-sided limit to exist, the limit from the left and the right have to be the same, and they're not. In this case, you've got from the left is negative 1 and from the right is positive 1. So as far as your derivative at 4 for this particular function, that does not exist. It is not differentiable at 4. And just like I said a while ago, this function would be differentiable at other places. Like if you took this exact same function, but you were asked about x equal 5, it would all work out. It would be differentiable. It's just not specifically at the 4. Now, you know what absolute value graphs look like. I mean, if you were to graph this, all absolute values, remember, are V-shaped. And actually, at x equal 4 is going to be the vertex. That is going to have a sharp turn. So, of course, as we saw earlier, sharp turns, your function would not be differentiable there.